I think it's time to start. Good morning, good afternoon, everybody, depending on where you are. I'm Badr Benjeloun, happy to meet you again in this new webinar of the INRA webinar series dedicated to discuss trends and innovations in agriculture. I would like to welcome all the participants from different countries for taking the time to attend this webinar. And I'm looking forward to their potential inputs and comments during the Q&A session. Before going further into this session, I would like to ask you all to mention your full names and affiliations on the participant lists. Participants who are not identified at all will be logged off in 5 minutes. Please also make sure your microphones are off throughout the session unless you are given the floor to speak. Thanks for your understanding. So before going further into this session, I would like to mention that we are pleased today to welcome to this webinar Her Excellency, the Ambassador of Romania to Morocco, Mrs. Maria Siubanu. She will give an opening speech. Then Mr. Dragos Sirbu, the Director of International Relations at the IAA company, will give a brief introduction to the company's activity. We will then have the main talk that will last up to 30 minutes. Then we will have the Q&A session as usual that will last up to 20 minutes. For the questions, please put them on the chat dashboard as the main presentation progresses. Participants will also be given the chance to ask their questions or provide comments orally by raising their electronic hand during the Q&A session. Questions can be asked in English or French. So my colleague, Dr. Hassan Husseini, will also introduce the guest speaker, for the main talk and the topic, and also will moderate the Q&A session. So now I will give the floor to Her Excellency, the Ambassador of Romania to Morocco, who will give her opening address. Thank you. The floor is yours, Mrs. Maria.
Good morning, everyone, and thank you very much for the invitation. I would like, first of all, to start by expressing my gratitude to the National Institute for Agronomic Research in Rabat, for my country fellows, those working in the Active Intervention in Atmosfera, for not necessarily for giving me a chance to say a few words, but for their positive and responsive and forthcoming reaction to an idea of cooperation, yet another project of cooperation between Romania and Morocco. And because I speak about these two countries, just let me give you very short highlights about our bilateral relations. And I would like to mention that each year that passes, the ties of friendship uniting Romania and Morocco are really very strong. And we know that to what extent our relations based on friendship, trust, and mutual respect are solid, and to what extent our cooperation is diversifying and deepens. And I'm really very delighted that our bilateral relations have such a long tradition. And from the start of my mandate here in Morocco, I set myself the main objective of giving them a qualitative boost. If we look to our bilateral agenda, we can congratulate ourselves on a series of great successes in areas that can progress further in the years to come. And I'm very proud that according to the statistical data available today, Morocco is the first trade partner of Romania in Africa and Middle East. And so just to give you in short, let's say not only the value but the quality of our relations, and the new products have been added to the list of our exchanges, but still there is a lot of room to further deepen our ties. And I learned, of course, with great enthusiasm, of a new possibility of cooperation and exchange between our countries, and through the ideas and the project you probably you can create and set up, and the education and the vocational training and exchange of information, cooperation in this direction has already a long tradition and has contributed to the consistency of our bilateral relations in the past. So now I cannot, I'm sorry, I cannot say much about the topic of the webinar, because I'm most likely the only person who is not an expert and has no knowledge and experience and background on the issue. But just, with my experience as ambassador to United Nations a few years ago, to stress how was, the topicality of the issue of climate change. And in countries like Romania and Morocco, where agriculture is a strategic sector for national economy, it comes in a natural way to invest a lot of energy, knowledge, and to make sure that this sector will continue to bring very important input in our national growth. And so a common climate change, a common enemy, so a common and collective response to fight to counter it. I am confident that the discussion of today will be just, another occasion where you can identify, I repeat, experts, not myself, identify issues to bring at least a small contribution to in this path. So once again, thanking very much for the opportunity. I wish you all the best, every success and I do hope that there will be a suivi follow-up to this webinar, and the cooperation in this field will just take shape with substance and future perspectives. Thank you very much for the invitation.
Thank you, Your Excellency, for this rich introduction on the importance of the cooperation between Morocco and Romania, and also the problematic of climate change. Thank you very much. Now I will give the floor to Mr. Dragos Sirbu, the Director of International Relations at the IAA company. The floor is yours. Your mic, please. Your microphone.
All right. Thank you. Good morning, Your Excellency, Ambassador, Distinguished Director of Morocco National Institute of Agronomy Research, ladies and gentlemen, thank you for being here today in this online event. We want to express our gratitude for Her Excellency, Ms. Ambassador Maria Ciobanu, for giving us the opportunity to present our company achievements in front of such an important audience. As is all known, climate change increases the frequency and intensity of weather hazards, such as droughts, floods, landslides, tornadoes, forces us to take action to prevent them. I am Dragos Sirbu, International Relations Manager at Active Interventii In Atmosfera, and it is a privilege and honor for me to present today in front of such an interesting audience. In the next hour, the company activities, our endeavor and perspectives to mitigate the impact of destructive meteorological phenomena such as hail and drought on the environment, agriculture, and properties. allow me to introduce Mr. Emil Sârbu, co-founder and company CEO, and Mr. Ali AbShaev, senior researcher and project scientist, our very close and important partner. They will present after me. Mr. AbShaev and I will present today, and we're open for any questions and discussions on this topic.
Thank you.
The agenda, my agenda for presentation, we will present who we are, what we do, and what can we provide. And after this, Mr. AbShaev will present more in depth about these topics. We are a private company from Romania with 30 years of business experience, one of the most active and largest private companies in its field around the world. We have 23 PhDs and several PhD students specialized in specific areas of activities. We do research projects, we do experiments, and we have a lot of engineers that do operational projects. We have 6 command posts and 84 launching points spread over Romania, and we cover 2.8 million hectares under our responsibility. To cover all this area, we have over 1,500 employees that work 24/7 or year-round. What we do anti-hail protection to protect against hail the crops, the infrastructure, and buildings, cars. And also we do rain enhancement because we know that water is becoming so scarce in these times. We use all the technology available, and we believe that we need to have an integrated system, a system that uses all the technology to carry the seeding material into the cloud. We use the aviation technology with special planes for cloud seeding. We use autonomous rockets launching system to carry the seeding material into the cloud. They are very good for anti-hail. Where we cannot use aviation or rocket, we use ground generators, automatic ground generators. And we are one of the first companies that developed a drone specifically for cloud seeding that can carry cloud seeding flares. We also use balloons, and we use specifically designed radars to exactly see the cloud properties. We have this type of planes specifically modified for cloud seeding with flares on their wings and on the belly, and we can see them in action on our radars. We have ground generators that work autonomously, and this is our design. We use rockets for anti-hail activity, and also balloons that are very good in situations that the other technologies cannot be used. We developed our drone. This is a special fixed wing drone that can fly to 5,000 meters and can transport 20 burn-in place flares. This is state of the art. There are very few companies that have this technology. I think maybe we are the only one. And we can provide several services. We are licensed in Romania and in whole European Union to provide trainings for weather modification activities. We have license to do this kind of trainings. We can do feasibility studies in a designated area. We can prepare a pilot project, and we can do local experiments. We have all the technical solutions that I presented in the last slides, and we have all the engineers and the scientists and the technicians prepared to do this kind of projects. Thank you very much. I will give the floor, if I may, now to the company CEO to say a few words.
Good morning. Your Excellency, Mrs. Ambassador Maria Ciobanu, Distinguished Director of Morocco National Institute of Agronomic Research, ladies and gentlemen. We have a pleasure to offer for any country they want to have this kind of technology for weather modification. We can offer radar, special radar meteorological, special soft and IT support. We can offer manufacture for rocket. We can offer training. Our training is recognized in all Europe because they have any diploma have the signature of Minister of Labor Ministry and Education Ministry. We can offer support and device for rocket, ground generator, drones, plane, and balloon. All the technology we offer have license in Romania. And we hope with our presentation to be interest for you. Thank you very much.
So thank you very much for these nice introductions about the IAA activities. So I will now give the floor to my colleague, Dr. Hassan Husseini, scientist in food processing technologies at INRA Meknes, who will moderate the rest of this session. The floor is yours, Dr. Husseini.
Thank you. Hello, everyone. I trust you have been enriched by insights shared in the initial segment of this session. I extend my gratitude to my colleague, Dr. Benjeloun, for steering us through an enlightening discussion. As we transition into the next phase of this captivating webinar, it's my privilege to assume the role of your tour moderator. Without further ado, let's now shift our attention to the main speaker today, who is Dr. Ali AbShaev. Ali AbShaev is a doctor scientist or doctor of science and associate professor at the Health Operation Research Center, Antigrad in Nalchik in Russia. Since 2016, he is a member of the expert team on weather modification on the World Meteorological Organization, and since 2021, he is a member of the International Commission on Cloud and Precipitation. In 1999 and 2001, he's gained his bachelor's and master's degree in the applied mathematics and informatics from Kabardian-Balkarian State University in Nalchik in Russia. And in 2001, he entered under postgraduate school of physical faculty of the same university, which is Kabardian-Balkarian State University, in the major of meteorology, climatology, agriculture, meteorology. In 2004, he earned his PhD, and the research was devoted to numerical solution of seeding materials in dispersion in hail clouds and optimization of their seeding. Then right after, in 2011, he got an academic status of associate professor in meteorology, climatology, and agricultural meteorology. His scientific career, in fact, began in 1999 at the Antigrad as a junior engineer. And right in 2005, he entered High Mountain Geophysical Institute of Russian Hydrometeorological Service in Nalchik in Russia as a senior research associate. In 2017, he was invited to the North Caucasus Federal University as invited professor at Cathedral of Theoretical Physics. Well, our esteemed speaker today has participated in several scientific projects and supplies of spatial systems, technology, and equipment applied by health operation services, meteorological services, and airports in several countries, including Russia, Armenia, Moldova, Ukraine, Tajikistan, Serbia, Romania, Bulgaria, and Macedonia. He guided about 10 scientific teams related to health operation problem and precipitation enhancement, which will be the main focus of his talk today. And from 2012 to 2017, he was responsible for organizing and conducting all Russian training courses on health operation. Our main speaker today has given many lectures and presentations and international scientific meetings. I cannot list them all, but the most important of which will be perhaps the World Meteorological Organization on the weather modification, conferences held in 2003 in Morocco, then in Turkey in 2007, and in Indonesia in 2011. Then the 6th international meeting of the World Meteorological Organization again on the hail separation in 2006, and in the European Geographical Conference in several countries. I can't not list them again. Also in Vienna, Austria, in Spain, and other lot of countries. Our speaker has published around 215 scientific papers, 4 guiding manuals on hail separation, and got 10 patents of invention. In 2007, our speaker with his team was awarded with the International Prize of the World Meteorological Organization and United Arab Emirates for outstanding achievements in the field of weather modification and development of rocket and radar methods of hail separation. He was also awarded by the prestigious prize named after the academician Fedorov of Russian Hydrometeorological Service for the book on organization and carrying out of hail separation projects. As you can see, our speaker has very impressive background and expertise. I just gave a short overview of his biography, but we can later on share his entire CV. But at the moment, let's dive into the heart of today's webinar, where our esteemed speaker will take us through an enlightening presentation entitled Navigating Nature, AAI's Insight into Weather Modification. In this presentation, the speaker will be focusing on hail separation and enhancement and rain enhancement technologies. I highly encourage all of you to actively engage this webinar by sharing your valuable comments and questions. You can do it, as my colleague has just said, or by writing down your comments, or raise your hand to be given the floor to deliver your comments or questions. Well, without any further ado or delay, I hand over the virtual podium to Dr. Ali AbShaev. Please, Dr. AbShaev, the floor is yours.
Thank you very much. It's my big pleasure to be with you today. At the beginning of my presentation, I would like to mention that my international side of my scientific career began in Morocco. In 2003, I attended and gave oral presentation at the 8th World Meteorological Organization International Conference on Weather Modification in the beautiful city of Casablanca. And I really hope that today's opportunity to discuss the problems associated with weather and adverse weather events will allow me once again to visit your wonderful country. And I will now share my screen. And let's start the presentation. And we will try to speak about some basics in the science of weather modification, and also cover some technological aspects of these technologies. And we will try to make a balance between science, technology, and different organizational, environmental aspects when one goes to implement this type of technologies. So, as I said before, in 2003, Morocco held a really nice international scientific event. It was the first conference in its kind in Africa and Morocco, and gathered together around 200 of scientists and stakeholders around the world. working in this field of weather modification. And let's speak about natural disasters. As we know from different reports, and especially by World Meteorological Organization, different regions and continents shows us unfortunately increasing trends in frequency of natural disasters, including Africa continent. And for example, over the last 40 years, around 150 million people died because of these different types of disasters. And nowadays, because of climate change and extreme weather, the number of such events, unfortunately, is going up. It also brings billions of dollars losses for agriculture, for infrastructure. And for example, for Morocco, over the last 40 years, total calculated losses made value 2.3 billion because of this type of weather events. And WMO report shows us that frequency of such events is also increasing since 1970. And main factors here are because of atmospheric and cloud processes. For example, droughts brought around 26% of total losses. Floods and storms gave 34 and 37% of total losses. And that is exactly the area of our expertise, and we will talk about these challenges, natural challenges today, and we may continue our discussions and talks after this meeting in additional webinars or through the direct communication. So are there any mitigating possibilities? To answer this complex question, I would suggest to dive into very small scale, into very small physical scale of cloud droplets, rain drops, ice crystals, snow pellets, hailstones, all these type of particles are part of cloud environment, cloud media. And all these types of particles are interacting with each others, and that raises a lot of physical processes between them, including electrification, coalescence, condensation, evaporation, and other processes. And despite this media is very complex, nature fortunately gave us some space, some possibilities to modify this very small scale environment by introducing special aerosols, glaciogenic aerosols and hygroscopic aerosols. We can modify spectrum of these cloud particles, and by extending the size, extending the spectrum, or broadening the spectrum of particles, we can trigger and stimulate formation of precipitation earlier than it can occur by nature, in natural processes. And this is called as weather modification. So the term weather modification is about modification of cloud processes. And consequences of that type of modification is manifested by additional precipitation, by reduced hail precipitation, and also there is a consequences for example, for electrification processes, which is additional topic. And this is the illustration of one of the first pioneering experiments carried out in 1946 in the United States. Here, the airplane passed through the top of cirrus cloud and released special pellets pellets of glaciogenic materials, and this triggered formation of ice crystals, which then converted into precipitation. And you can see exactly the trajectory of the airplane brought clearing of cloud. And this portion of cloud produced precipitation. So the evidence that technology works is very clear. And since that time, many groups around the world over many decades have carried out deep research, scientific and technological research. And nowadays we have much more advanced technology and physical understanding how this interaction, interventions in the cloud environment can be done, and how they could be done in an efficient way. Here I would like to show you a short video courteously provided by United Arab Emirates National Center of Meteorology and United Arab Emirates Rain Enhancement Research Program, which is one of the brilliant program nowadays, international program, and a lot of different new knowledge and new technologies come from this specific program. And for example, here you will see how raindrops form on artificial hygroscopic particles. This project was done by Professor Linda Zhu from Khalifa University from United Arab Emirates. And on the right-hand side, you can see how raindrops form much faster on novel seeding material, salty material covered with titanium dioxide nanoparticles. And this is a direct modification of the cloud environment. And this modification leads to earlier precipitation and to more precipitation on the ground than it can happen in a natural course of processes. So now I will talk about hail suppression direction. So we all know that hail phenomena is common for many regions and continents, and it brings high rate of losses for agriculture, for infrastructure. Sometimes people die, animals, birds. And there are different approaches how to mitigate it. For example, here you can see hail nets. In this picture, you can see that technology works, and it is very evident. Hail damage and no hail damage under the hail nets. With cloud seeding, situation is more complicated, but we will speak about it. But sometimes even this technology doesn't work. This is in my home land, and you can see that even hail nets sometimes cannot prevent hail losses. And this is how we do, what do we do in this direction? So the core idea behind this implementation of this technology is producing more ice crystals than it occur naturally in the cloud. And the competition between natural and artificial crystals, and also washing out cloud water content, reduces the probability of hail risk. And here you can see some basics of technology where we release seeding material, which is mainly based on silver iodide aerosol. And we release a very small amount of this material, and size of particles is like 0.1 micron, very tiny particle. And because of that, the concentration of these particles in the cloud is very high. 1 gram of silver iodide seeding material produces around 10 in power 15 particles, artificial ice crystals from 1 gram of seeding material. And it's a very high value. And this illustration how we launch rockets to so-called feeder clouds, feeder parts of clouds. And this is an illustration of real seeding of hailstorm. You can see a side of main hail cell. You can see blue lines which represent trajectories of anti-hail rockets. And for one very severe hailstorm, we can launch several tens of rockets per 1 or 2 minutes. It's a unique technology in this kind that can provide us very fast seeding of required cloud volume in any time of the day, despite night or day visibility, and despite of existence of high turbulence and high wind speed. And we can do it very fast. So these are advantages of rocket systems. Of course, it's not a panacea, and the aircraft technology, which we will speak about a bit later, has another advantage, like covering big areas. And combination of both technologies, rocket and aircraft technology, may give us even more efficient intervention to cloud environment. According to our statistical analysis, I will briefly show you that, for example, here we compared 200 seeded hailstorms and 200 similar control storms which were not seeded. And we compared the lifetime of the different characteristics calculated using radar data. And it showed us that seeded storms lifetime was reduced significantly comparing to natural clouds. And they produce less heavy precipitation, but light and moderate precipitation were more extended comparing to severe hailstorms, to seeded storms. Compared to not seeded storms, sorry. And we classify storms on 4 different categories depending on their severity, on their power, and depending on the severity of storm, the lifetime of storm is reduced depending on the category, on the class of storm. For example, on the A part of the figure, you can see reduction of lifetime of potentially hail dangerous clouds, the bold line, and you can see that lifetime was reduced by around 40 minutes comparing to natural not seeded cloud. For hail cell, we have similar effect. For severe cells, hail cells, we have less prominent reduction because of very high energy and development velocity of this storm. So the earlier we start to seed hail cell, the better is the result. And this data was obtained by processing data in different regions, including Latin America, Asia, Transcaucasia, Moldova, and other regions. And here for you can see map of hail kinetic energy. The black contour is protected area, and outside this area it's not protected. And you can see the big difference in hail kinetic energy inside protected area and outside. And this map was calculated for the whole 2024, the year of 2004. And the total kinetic energy was calculated for all 12 months. And we can see very evidently that technology works. And again, integrating together all these results from different regions, the average reduction of hail kinetic energy was between 66 to 94%. It varies in different regions, in different years, but on the average, hail losses were reduced by 7 times. And it's really important to note that expenses for such protection were paid back in 5 to 15 times, depending on the type of crops produced in one region or another region. So let us go to rain enhancement direction. We know that precipitation is unevenly distributed all over the world, and even some inside 1 year we have dry periods and we have rainy periods. So, and this irregularity brings a lot of problems and challenges for the population, for the agriculture. And nowadays there are different technologies like water desalination, extraction of groundwater, extraction of offshore water. But all these types of technologies cost a lot. Sorry. For example, desalination program, it takes billions and billions of dollars everywhere to build new plants to desalinate salty water, and unfortunately it doesn't solve the problem. In addition to these solutions, rain enhancement through cloud seeding is one of the viable solutions which can help to mitigate in some scale this global issue. And the physical pillow for that is our understanding and our knowledge that atmosphere always contain a very huge amount of water as a vapor. And this vapor makes many cycles every year. And by increasing precipitation in some part, in some local point, we will not change the global balance. And this means that we can use this technology without any caution that it will stall the rain from other region, or it will make some global changes. It doesn't work like this. It's a local intervention. And here, this is another video, short video, provided by National Center of Meteorology of United Arab Emirates, and you will see how cloud seeding works in order to enhance precipitation. So this is a simple illustration how this technology is implemented. However, it's not that simple, and this is really very interesting technology, and a lot of physical processes are behind this, and there is the combination of chemical science, of basic physics, of cloud physics, meteorology, IT, and majority of scientific fields. In order to make good job, we need to implement the best of our knowledge gained in different fields of the science and technology. And for example, here to understand what nature give us, is there the potential to increase precipitation, or we are on a very or we are on the edge of the opportunities, and we have no any space to trigger more precipitation. And for that purposes, we did analysis of global climate era 5 data, and this was a case study for Minas Gerais province of Brazil, and we published a paper last year. You will see later the link, and you can find more information there. And here we analyzed 3 different substances. One is a rainwater content integrated over 50 years period for this region, over 50 years, and also cloud liquid water content, which is cloud droplets, and also cloud ice water content, which is ice crystals, hailstones, snow pellets, etc. And blue curve is a rainwater content of clouds. A horizontal axis is is height in kilometers, and vertical axis is a specific water content integrated over 50 years period. And we integrated all clouds which developed over this region over 50 years, and found that a blue curve, blue zone, which is rainwater content, is only 10–20% of the total cloud water content. It means that only small fraction of water in the cloud produced rain. The rest of the water content evaporated in atmosphere without production rain. And even ice water content in this region, snow almost never happen, never fall in this region, but ice water content in this region was higher than rainwater content on the ground. So it shows us that nature itself produces only a small portion of precipitation from the total cloud water content. And it means that we have a very big, huge opportunity to do something if we, to enhance precipitation if we use proper technology and proper technical systems. And that is what is encouraging us in this direction as a scientist. And this study was published in this paper. You can find more information there. And also another study by our group showed us that, for example, comparing one severe storm and capacity of desalination plants around the world. And we found that one similar storm produces much more rainwater, fresh rainwater, potable water than all desalination plants around the world. Like one storm produces 3 to 30 times more potable water than all desalination plants around the world. And let's imagine how many similar storms we have on our planet in one moment. And let's show again to the previous slide where we found that storm produces only 10 to 20% precipitation out of the total water content. And if we increase this precipitation rate by a small fraction, by several percent, then the profit and the outcome of this intervention is would be very high and very reasonable. And according to assessment of different projects around the world in different regions, we know that cost of additional rainwater from the cloud seeding is the lowest comparing to other technologies, and it costs around 0.1 to 0.2 American dollar per 1 cubic meter or per 1 ton of such rainwater. For example, water from desalination costs with even very new technologies, it costs around 1 to American dollars, so 10 times more. And also, as scientists, we do a lot of different studies. And in this specific study, which you can find a link here, we found that seeded clouds in hail suppression operations produces several times more intensive precipitation compared to not seeded clouds. And this is a very interesting result, as well as different other characteristics are changed. So it also shows that technology generally works. And we know from agriculture science, we know that supplying of additional water at the early stage of vegetation increases yield of harvest much in higher scales. So by supplying small amount of additional water, we can increase the yield. Maybe by 20%, maybe by 200%, depending on the plant type. And by implementing this technology, we can do really a big difference for the harvest production. Again, if we use proper systems and if we do right job and improve every components of technology. And rocket systems, we use very light rockets, and they are very safe. And each one rocket releases a big amount of artificial nucleus, producing artificial ice crystals. And we don't need too much rockets. With one rocket, we can deliver seeding amount comparable to one pass of airplane. But airplane advantage is that it can cover big areas. So we have advanced rocket systems with automated robotized systems. Everything is computerized, and remotely people can control the process. And such sites could be autonomous without any person. And this is a video showing the launching of anti-hail rockets. This system was installed in the Republic of Moldova. So everything is guided remotely from a control panel. And to establish that technology, we need weather radar, we need communication links, we need the control site where the experienced personnel will make decisions and will control the whole process, and remote launchers or airplanes. And we have our sophisticated software systems, which give us a lot of meteorological information about clouds, about the characteristics. They help us to make the decision when to start cloud seeding, how much should we, how long should we seed, and when to stop. And we can see trajectories of airplanes on the background of the maps, trajectories of rockets. And this is a really nice picture. I love this picture very much. It's a three-dimensional representation of a hailstorm. And you can see how beautiful nature is it. And but we want to modify a bit to transform this severe storm into more moderate storm, moderate object. And in case it produces more precipitation and less heavy precipitation, it will be it will bring a lot of positive consequences for agriculture, for poor people, for small farms. And many people ask us about environmental impact of using this type of aerosols. And according to different studies by different groups, the common answer for this question is that that is a very local intervention. An amount of seeding material we released into atmosphere and specifically to clouds is very small, and concentration of different pollutants is several to hundreds and thousands times less than natural content of these substances in atmosphere. In atmosphere, in the soil, in water basins. So the common answer is that it does not produce any harmful effect. This is illustration, as Dragoș showed before. This is illustration of ground generators. I know that in Morocco you made some experiments with ground generators in a mountain area, and we produce such generators. They are automatic and uses all advances of technology available nowadays. And this is another system, which is automated balloon system. Each one balloon delivers seeding materials to atmosphere when specific clouds pass over the area. And we own several weather radars, S-band weather radars, and we can use them in different experiments, and they are very useful because of the sophisticated software and very reliable hardware side. And this is another type of technology. This is UAV, and it allows to implement advantages of aircraft technologies, but without without pilots. And it's available in 24/7. And now in these days, we're making flight tests of this first prototype. And it can bring up to 40 flares of seeding materials, both hygroscopic or glaciogenic. And combining together all these different systems may help us to address different weather conditions, different features in different regions. In some regions, we can utilize one type of technology. In another region, we can utilize other type. But in optimal way, in optimal case, utilization, deployment of all these types of technologies is the best, maybe the best one. So we are making international collaboration with different companies and academia and other groups around the world. And this allowed us to gain experience of implementation these technologies in different regions of the world, and to improve the technology and to make it more reliable. So our team can provide to solve And to mitigate these natural problems, we can provide engineering and expertise service. We can train seeding operators. We can help to install different all mentioned types of technical systems, including rocket systems, ground generators, airplane systems, balloons, and drones, and also weather radars. So this is a holistic way. This is a so-called on-K solution, and we can help in establishing sophisticated state-of-the-art project. And also it should be combined with scientific research, with feasibility study, and specific studies should be carried out to understand available natural conditions, cloud frequencies, A types, occurrence, in order to understand what could be possible effect of implementation that kind of technologies, and which technologies would be more optimal and which would be less optimal. So this is a team, and this is just the head of the team. And as Dragos said at the beginning, the company combined together more than 1,000 people, different type of engineers, scientists, experts, managers, and students. So we are ready to help you in improving your cloud seeding program, and to help to make physical study, and to analyze results of cloud seeding. And it's only efficient way to do international collaboration. And because nature, there are a lot of common features, and there are a lot of specific features in different regions. So by combining all these features together, we can construct the whole picture of nature, the whole picture of clouds, and it definitely should help many people around the world to live a better life, and to produce more harvest, to live in a safe environment. And so we are happy to collaborate and to bring our expertise and knowledge to enhance capacity of your program. And thank you very much for your attention. And we will be happy to get your questions. In case we don't have enough time to address your question at this meeting, we will collect your contacts and we'll respond all your questions after meeting. Thank you very much.
Okay, thank you so much, Dr. AbShaev, for your insightful and thoughtful provoking presentation. Thank you either for respecting the frame time allocated to your main presentation. Your presentation has provided us with valuable insights and has certainly sparked interesting discussions. We appreciate the depth of knowledge and expertise you shared with us today on the health separation and the rain enhancement technologies. During your talk, you pointed out the environmental disaster, particularly the hail, drought, flood, and so on. And then you shifted to the mean cutting technologies used to suppress those disaster and the impact on the agricultural activities and human activities as well. And you kindly shared with us some videos, even though we couldn't really hear the speech or the narration while you were sharing the videos. But I guess the attendees, anyone of the attendees who wishes to watch again the videos, they can contact you directly and you can provide them with the videos. It was very interesting, and I'm excited to open the floor to discussion. But before that, and before giving the floor to my friend and colleague Viorel Ionescu, I just forgot to give a short background to the attendees about how we came to this webinar, to organize this webinar. The first discussions were started the past year with my colleague, Dr. Razzouk from INRA, and I, and with Viorel on the panel of the IAA company. We had several discussions and there were several meetings. It was during last year scheduled to come and visit Romania to have a closer and deep understanding of your technologies and how they are used and the impact. But we couldn't make it through, I guess, and then we relaunched discussions again, Viorel and I, and we thought it will be helpful and interesting to have this webinar as a first step to get known your technology. Now, before giving the floor, as I said, to the Q&A session, please, my friend Viorel, the floor is yours. You have 3 minutes to deliver your very short talk.
Thank you very much for inviting. I will salute great for our Excellency Mrs. Ambassador Maria Ciobanu, and for our audience from National Institute for Research from Agriculture from Morocco. For my friends Lachchen, thank you very much again. Mr. Ali speak in the technical parts, academic parts, but I want now to speak in the farmer words, because our company already protect 2.8 million hectares in Romania, and has the capacity to protect not only the agricultural land, but also 1.2 million hectares with industrial zone, with small village cities. And it's also a good impact for insurance and also to protect people. But not only the production, because it's our food, but also the people and the people, crops, and animals. In 2030, our company have planning to protect more than 7.5 million hectares, additional with 2.5 million hectares with industrial zooming and village. Our company are ready to work together with Morocco in this field to get our experience and also to training people in Romania, because our company has the biggest company in the world, private company, and has the solution with the rockets, with the plane, with the balloons, and we see our drones that is unique in the world. And I think after this discussion, get also our invitation for INRA and for the people that want to see our activity in Romania. I think it's enough, and I want to speak this in the word from the farmers and not academic words. Thank you very much.
Okay, thank you, my friend Viorel. Now, I guess it's time to open the floor for questions and answers session. Once again, please, whomever wants to interact, please raise your virtual hand, or you can either write down your comments or questions in the chat box. Let's see if we have any question in the chat box. We didn't have any question yet. Maybe I should start with one triggering question to Dr. Magometovich. It was a very interesting presentation with very deep insights and scientific details. And just I was wondering, what are the specific limitations in effectively implementing such technologies used for health separations and rain enhancement, and whether there is any impact, particularly when it's used on areas that are close to civil agglomerations. Is there any impact?
Okay, thank you very much. To respond this question, I think it's better to separate hail separation and rain enhancement directions from each other, because despite clouds are the same, technology is in majority the same, but the kind we do this intervention is different. So with hail separation, we try to decrease heaviest part of precipitation, including hail and severe rain, and to extend moderate and light precipitation, including space and time. And the evidence from different programs show us that in hail suppression projects, we have extended precipitation, moderate and light type over large area. And this is really very important and interesting aspect. It works for hail suppression, and at the same time it works for rain enhancement. With rain enhancement technology, our aim is to stimulate more precipitation from existing natural clouds, which naturally produce precipitation, but not much precipitation, or do not produce precipitation at all. So in terms of goals, there are different features how to implement, how much seeding material to release to cloud, in which part of cloud to release it. But this is manageable physics, and we have understanding. Of course, nature is very complex, but thanks to long-term development, we have many type of systems and the different solutions how to make this intervention more successful. And speaking about technical limitations, with rocket systems, when this system is implemented in one region or another region, before that, we always establish a direct communication between seeding agency, cloud seeding agency, and FAA, aviation authorities. And only that direct communication gives a permission and gives allowance to launch rockets or even airplanes to one cloud or another cloud. So everything is very strictly prescribed and done in a strict way. And because of that, for many years of implementation in different regions, we have no any accident from using these technologies. And also, I can mention that usually we launch rockets to severe storms, and airplanes, if you ask about civil flights, usually don't approach severe storms in vicinity of 30 to 50 kilometers, depending on regulations in one country or another country. And we launch rockets exactly to these clouds, and we launch rockets to height a layer around 3 to 5 kilometers. Usually civil flights pass on high altitudes like 10 kilometers, and we don't work in this flight layer. Only if there is airport very nearby to the rocket site and there is taking off or landing of airplane, in this moment, the IAA restricts us, prohibit to launch rocket. So this is very flexible and very strict communication between bodies, and this makes this works very safe.
Okay, that's great. Thank you for answering this question. I may have another question. I saw in your presentation that we can use the silver iodide as a nanoparticle to seed in the clouds. And I'm just wondering, have we enough data about the biodegradability of such particles and whether it's safe to use it in the atmosphere or not? It joined the first question, particularly I want to focus on the nanoparticles used in the cloud seeding. Are they safe, and what do we know about their biodegradability? Biodegradability in the atmosphere.
Yeah, thank you very much. Again, I would like to separate silver iodide from this salty particle with nano shell. And silver iodide in these terms is more harmful, but if you breathe with this aerosol directly, in our case, we release these particles very high in atmosphere and release it, and it is dispersed over very large space, many tens of cubic kilometers, and several tens of 100 grams of silver iodide distributed in this large space is very negligible. And again, our scientists, our elder scientists, they made a lot of research in this direction, and they looked for content of silver iodide in regions where cloud seeding technology was implemented for more than 50 years, and they looked for content of silver iodide in the soil, in bodies of trees, bushes, in water basins, in atmosphere, and they found everywhere that the content of silver iodide is 1,000 or even more times less than natural content of these substances in environment. So and it is easy to understand because our intervention is very local. But nature itself can brings a lot of aerosols from different regions, and it contaminates like one volcano contaminates almost whole planet may contaminate. But our intervention is very small, very local, and in terms we use very small amount of silver iodide, and it's distributed over long time and over large space. And speaking about nano particles are used to cover standard ordinary salt crystals, which are very abundant in atmosphere in almost all regions, especially in nearby the coastal area. Salty particles exist everywhere, and the project for where scientists designed this new novel material, they try to enhance efficacy of hygroscopic particles to produce larger droplets in a faster period of time. And that was obtained by using small nano particles of titanium dioxide. They covered salt crystals by nanoparticles of titanium dioxide, and titanium dioxide is widely used in chocolate, in women cosmetics, and in food production, so it's safe.
Okay, thank you again. And what if we use those particles, the silver iodide particles, in the area which is near to a civil agglomeration? Is there, and after several utilizations, will there be any harmful impact on the civilians?
You mean in terms of health and ecology?
Exactly.
Our studies by many groups in different regions showed that we can't detect any evidence that it brings problems to people's health or to animals or to plants because a very small amount of these materials used for cloud seeding. In order to produce such harmful effect, we need to spend many tons of these materials in a fixed area. But actually, we release just maximum several kilo of silver iodide over much larger area. So again, the concentration of these particles is very negligible comparing to natural existence of silver in atmosphere in the soil.
Okay, thank you again for your insights. And maybe my last question before I check again, let me just check the chat box. Okay, I really encourage all the attendees to interact if they have any comments or a question to our esteemed speaker today or to the panel of the AII company. Maybe my last comment or question will be about the area covered by each technology, because during our Q&A's discussion, I saw that you pay attention to answer to each of the questions depending on which technology we're talking about. So what are the range covered by each of those technologies you have presented in your talk?
Generally, area of experiment or long-term project should be quite big. For example, for hail suppression, because the scale of hailstorm is big, it may be one hailstorm may be larger than 100 square kilometers. And sometimes we see hailstorms which one dimension is like 30 kilometers, 40 kilometers and more. Because of that, we need to start intervention to such storms as soon as possible. And if already major hailstorm invaded into your area, into your agricultural zone, you have no time to make any change. But if you started intervention before it entered your target area, so you have a chance to reduce the probability of severe precipitation and hail precipitation over your target area. Because of that, usually we try to cover areas like approximately by 100 by 100 kilometer. Like Viorel mentioned, in Romania, we are very close to cover 2.5 million hectares. Even this area is not sufficient for the country, and probably step by step the area will be expanded year by year. But the minimum area to make an experiment for hail suppression would be at least 100,000 hectares. 100,000 hectares at least. For rain enhancement, situation is very close. It's not that critical like for hail suppression, because we have more time, we have less critical requirements for amount of seeding material to be delivered to cloud, and so it's a bit easier to work for enhancing rain. So, but it's generally comparable to hail separation area. And also in areas where there is existed hail separation infrastructure, we suggest to run rain enhancement operations, because infrastructure is already there, and it's easier and cheaper to run both interventions, both type of technologies, if you have available infrastructure, rocket or aircraft infrastructure.
Okay, thank you again. I guess there is no question in the chat box. There is one point that, or one aspect that was captivating in your presentation, in your talk, when you're talking about the cost of the technology compared to the, mainly for the rain enhancement compared to the desalination. When it comes to the cost, it's much lower. Is 200% lower than water desalination, which is very interesting. With such a rate, I guess it's very promising technology. And before you answer this question, or before we deliver your comment, also I was going to ask you about the feasibility or the procedure that is usually followed to implement such technologies. But I guess I remember you answered that question in your slides, talking about the study of the cloud frequency and the feasibility study, which is specific to each area. If you have any additional comment on that regard, it will be very helpful.
Yeah, you are absolutely true. Comparison between cloud seeding and seawater desalination shows us very big difference in terms of outcomes. Nowadays, many countries invest billions and billions of dollars to desalination program, but capacity of all desalination program is several times less than capacity of potable rainwater production of one severe storm. And let us invest not only to desalination, which is very important and for people living in desert and semi-arid areas, but let us also look at development of further development of cloud seeding and rain enhancement field. Because it's, as I mentioned, as I tried to demonstrate in presentation, nature gave us very huge opportunities, very big space to improve these technologies, to enhance, to improve potable water balance in regions suffering from this problem. And the cost of additional potable water, rainwater, is the lowest comparing with any other type of technology. No one technology can compete with cloud seeding in this aspect. Same is about hail separation. Installing hail nets costs several thousand American dollars per 1 hectare to protect area. With hail separation, the cost of cloud seeding operation varies from country to country. But it varies from $3 to $30 maybe dollars per hectare. Yeah, and you can compare $30,000 per hectare by hail nets and $30 per hectare by using cloud seeding, and it's uncomparable. And total cost for establishing and for carrying out cloud seeding operation, both for rain enhancement and for hail suppression, depending on local characteristics of producing agriculture products and infrastructure and so on, the profit makes value from 5 to 20 times. So if you spend $1, you can save from 5 to 20 or even more dollars. And in these terms, it's the most profitable business comparing with other types of businesses, oil production, extraction, gas extraction. So cloud seeding in this aspect is a more profitable business. So yeah, did I respond to your question?
Yeah, you really respond with further details, and thank you for that. It was very interesting presentation and really very insightful discussion. I understand that your presentation was very intense in when it comes to data, and I guess that the attendees liked it, but they're not really familiar with your field of study. And I remember we had a discussion yesterday when you told me that what you have presented focuses only on the hailstorm suppression and rain enhancement, but your field of expertise it goes beyond that two fields of studies, and maybe we'll have other opportunities to where you can share with us your valuable insights and data regarding other aspects of this interesting topic. Now, since we don't have any additional comments or questions, I extend again my gratitude to you, Dr. AbShaev, for your insightful and thought-provoking presentation. We appreciate the depth of knowledge and expertise you shared with us today. Again, on the hail separation and rain enhancement technologies. Sure, your presentation has provided us with valuable insights, as I said earlier, and certainly sparked interesting discussion.
Thank you very much.
Well, as we move toward the end of this webinar, because I guess we have exceeded the time allocated to this session, to this very interesting webinar. We were very delighted to have you, all of you, Dr. AbShaev, and all the IAA panelists, and very particularly Her Excellency, the Ambassador of Romania to Morocco. So I would like to mention that when you leave the webinar, for the attendees, you will get directed to a survey. Please use it to provide us with your assessment. It will be helpful for future improvements of the INRA webinar series. You can also request your certificate of attendance through the same link. Also, speaking of myself and on behalf of the organizers, I would like to thank you very much, our guest speakers, for their time, availability, and the preparation of today's webinar, and for sharing with us with their deep knowledge and experience. And I warmly thank Her Excellency, the Ambassador of Romania, Maria Ciobanu, and all the IAA panelists, as I said before, for enriching this webinar with their speeches. Many thanks go to all the participants, and extend especially to my colleagues, Boutaina Abidou, Uthman Sabata, Iman Tahmi Alami, Radda Tirazi, Nordin Bhari, and Abdelaziz Yesri, and all the scientific committee of the INRA webinar series for the crucial contribution to the organization of this series. Now, my colleagues from IAA, would you like to say something at the end of this session? Please, if anyone wants to add a comment, the floor is yours.
Thank you very much for giving us the opportunity to present today. I hope our information was interesting for the audience. Thank you very much.
Thank you so much. For sure, it was very interesting. And as I told you before, that this webinar will be made public through our social platforms, so it can reach to a broader audience. We thank you for your time, for availability, as I said. And if there is any other comments, so I told you, thank you to the other attendance, thank you for assisting to this interesting webinar, and let's see you in the next session. Thank you so much. Bye-bye.